All right, let's make a video of the chapter Unit 3 test in 153. So we were supposed to figure out which of these has horizontal and oblique and what are they. So this has a degree 2, this has a degree 2 if I multiplied it out. So the horizontal asymptote will be y equal the ratio of the leading coefficients. This has got minus 2. This multiplied together would be 1x squared. So it's going to be minus 2 to 1 or minus 2. On this one, the degree is 2, and this is degree is 3. So higher in the denominator than the numerator. So it's going to go y equals 0. This, the degree of the numerator, is more than the denominator. So it's going to go to this divided into that, so that's going to be 2x plus 1 into negative 5x squared plus 3x plus 10. 2 goes in there, negative 2.5x times. 2.5 times that is negative 5x squared. 2.5, that is negative 2.5x. Draw the line and change the signs. When we add, we get 5.5x plus 10. 2 times what is 5.5? That would be half of 5.5 would be 2.75. And I can stop there because that will be the equation of the line. I can take that times this and times that and add and subtract and get whatever the remainder is, but I don't need the remainder for the oblique asymptote. Okay, on this one. So y equals, so the numerator tells me the x-intercepts, and there's 1 at 1, so it's going to be x minus 1. And it's straight through. Bounces at 4, so it's going to be x minus 4 twice. The vertical asymptotes, see this one's going this way, this one, so it's probably about minus 1, so that means x plus 1 would be in the denominator. They both go in the same direction there, so that has to be either squared or cubed, or squared or fourth. Has to be even. It looks like there's another one here at, let's see, that's 2, that's 4. Looks like it's closer to the middle 3. So that looks like it's got to be x minus 3 and squared because they go the same direction. And if this was the case, 2 and 1, it would have the degree of the numerator is 3, the degree of the denominator is 4, so it would go towards 0. And it looks like it could be going towards 0. And it has a y-intercept of negative 4. So if I put 0 in for all the x's, I would get negative 1 times 16 over 1 times 9 times some number that I have to put here, and that's supposed to come out to be negative 4. So I will have to multiply, see that's negative 16 over 9 times a equals negative 4. So I'll multiply both sides by 9 over negative 16. And a would be, see, negative into a negative. They would cancel, and the 4 in here would be 9/4. Next page. So let's take a look at, I've already entered into y equals the numerator. So I'm going to graph it so I can factor it. And it goes through -3, -1. So that means it goes to x plus 3, x plus 1, and it went straight through, and it goes through a half. So x plus 1/2. And there's a 2 in front, so it's 2 times this. I could take the 2 times this and be 2x plus 1 would be another way to write that factor. And now let's look at the denominator. So turn that one off and turn that one on. That's the denominator, hopefully typed in correctly. And so I'm going to push graph. And it bounces at -2. So x plus 2 twice. And it goes through at -1. So it's x plus 1. And that's it. And the leading coefficient's 1, and this would have 1. So looks like that would be the factored form. And since x plus 1 is in both of them, that means there's a hole at -1. And to figure out where that hole is in the y direction, I cross those out and I take what's left and put -1. So I'd have 2, and -1 plus 3 is 2, and -1 plus 1/2 is -1/2, and -1 plus 2 is 1 squared is 1, and that's gone. So I get 2 times 2 is 4 times -1/2 is, that would be -1 times 2, which is -2. So that's the hole. Vertical asymptotes at -2 at x equal -2. It's a double, so it's same direction. And that was a hole, so that's the only vertical asymptote. The behavior, they go at the same direction because it's degree 2. Determine the horizontal oblique. The degree of the numerator and denominator are the same, so it's y equal the ratio of the leading coefficients, 2 to 1, which is 2. X-intercepts, it goes through -3, 0. That was where the hole is, and it goes through at -1/2, 0. And this happens once, so it's straight through. And so is this one, because it's degree 1 and degree 1, and that's the hole. So when x gets very large, it's going to approach y equal 2. Approaches a height of 2. What are the y-intercepts? Well, if all the x's were 0, we'd be -3/4. X's are 0, it's -3/4. Local max and min. So now I'm ready to look at the equation. So I'm going to go back here and turn that one off and do y1 divided by y2, which is what the function is. So turn that one on and graph. And I can see that it's trying to approach 2. I have a horizontal asymptote at 2. And I have a vertical asymptote. And let's see, we decided the vertical was at x equal -2. there's a hole at -1, -2. There's, let's see, x-intercept at -3. There's an x-intercept at -1/2. Let me check that. No, it's a +1/2. This must have been -1/2 here. And so this is at +1/2. +1/2. And it has a y-intercept at -3/4. And it looks like it goes up and then comes down again a little bit. So it's going to go closer and closer to this, come up, and it's going to go higher and then come down. And it goes through here, through the hole, through there, and it gets closer and closer to this line. And they both go in the same direction here. That's a sketch showing the main features of this. And so it looks like there's a local maximum somewhere in there. So I'm going to go to my graph again and say I'm going to look for a maximum in there. So second, calculate a maximum somewhere between -8 and -2, maybe -5. It says it's -5 1/3 about, but the height is 2.45. Maximum is 2.45 at -5 1/3. -5.33, 2.45. That's kind of a key spot. I'll put it on there. You don't have to for that. Is there any minimums? Well, if this goes up and then comes down and just keeps getting closer and closer to 2, and this keeps going up to 2, there is no minimum. Sketch the graph. And now, when is the graph, the y values, for what x's are the y values less than or equal to 0? The y values are less than or equal to 0 from -3 to -2. It doesn't exist at -2. At -3, it's equal to 0, and we wanted that, so we got to have a bracket on that one. It's less than 0 in here, but at -1 it disappears. So we have to go from -2 to -1, not including either side, and then from -1, not including it, up to 1/2 and including it. Including solid bracket. And that's that problem. Now I'm going to go back and check and make sure that is -1/2. I believe it is, so I'm going to turn that one on and turn this one off and graph. And it went through +1/2, so I should have written x -1/2 originally. Okay, now we're ready to do some simplifying. On an odd root, if I see a minus, that comes out automatically. Even roots, we get complex numbers, so we don't want to have negatives on even roots. Now 24 is 2 times 12, which is 2 times 6, which is 2 times 3. We're taking them out in groups of 3. There are 3 2's, so I can put a 2 on the outside. A 3 would still be inside the radical. 5 x's, taking them out in 3, so I'd get an x out and there would still be 2 left. 2 y's, not enough to take any out, so they stay inside. And this is an odd root, so I don't need to put absolute value on any of the variables I come out if they come out in an odd number. So that one's done. This one, this is an even root, so I have to watch out for absolute value. Now 12 is 2 times 6, which is 2 times 3. I got a pair of 2's. This is square root, so I take out a pair of 2's times the negative 2, so that's negative 4. And I got 6 x's. Every pair comes out, so there are 3 pairs. So that comes out as x cubed, even root, odd number out, so we have to put absolute value. And there'd be a 3 left in the square root. Minus, there's only a single 3, but there's a pair of x's. That'll come out as an x, so I'll get 2 absolute value of x because it's an even root and an odd number out. And I get a 3 left inside. Now, some of you tried to do some simplifying. The only thing you really could do here is maybe factor out something. These are not like terms, but x to the third is x squared times absolute value of x. That would be absolute value of x to the third. And so I've got, 3. I've got absolute value of x times the square root of 3 in both of these. I could factor that out and go absolute value of x times the square root of 3, parenthesis, negative 4x squared minus 2. Actually, it looks like I could factor out a minus 2 also. So it could be minus 2 absolute value of x square root of 3, and what would be left in would be 2x squared minus 1, plus 1. But this would have been good enough right there. This one, it says I have this thing twice under cube roots. So I have a cube root, so I'm taking them out in groups of 3, and I have 9, which is 3 times 3 twice. So there's 2 9s. I have x to the 5th twice. So that's x to the 10 x's. And I have y to the 4th twice. And I'm taking them out in groups of 3. 3 of the 3's will come out as a 3. 1 will be still inside. 10 x's. So that's 3 groups of 3, making 9 of them. And that leaves 1 in. I got 8 y's. So that's 2 groups of 3. That makes 6 of them. And that leaves 2 of them inside. All right, to solve, we like to go to a common base. Looks like this is 2 to the negative 3. 2 squared is 4 to the 3x plus 2 equals 2 to the 4th is 16 to the 2x minus 3. So this is 2 to the minus 3 times 2. When you got a power to a power, you multiply, and we get 6x plus 4 equals 2 to the 8x minus 12. And when you multiply, you add the powers. So negative 3 plus 6x plus 4 is 2 to the 6x plus 1 equals 2 to the 8x minus 12. So the single bases, both the same, so now the powers must be the same. So 6x plus 1 must equal 8x minus 12. If I subtract 6x from both sides, I get 1 equals 2x minus 12. Add 12. Divide by 2. X is 13 halves, or 6 1/2. Got 9s and 27s. They're all powers of 3. So we got 3 squared to the x equals 3 squared times 3 cubed is 27 to the x plus 5. So we have 3 to the 2x, 3 to the 2 times 3 to the 3x plus 15, because we've got to take this times that power, all of it. And here we have to add when you multiply, so we get 3 to the 2x equals 3 to the 3x plus 17. And now I've got same base, single bases on each side, so the powers must be the same. 2x equals 3x plus 17. Subtract 3x and I get negative x equals 17. X equals negative 17. And now the last page, domain. The fourth root, that means this has to be positive. 2 minus x has to be positive or 0. Add x to both sides and we get 2 is greater than or equal to x. Or x is less than or equal to 2. So that would be from negative infinity is less than 2 up to 2 and including 2. If I'm subtracting them, all these numbers subtracted there will be 0 or positive. Odd root, x can be anything. All reals, or negative infinity to infinity. Population of bacteria in the dish. After 3 hours, we put 3 in there and we get 9,000 divided by 9 plus 15, which is 9,000 divided by 24, 375. Thousand bacteria. How much is expected to remain after a lot of hours? Well, if t gets very large, a lot, this is going to be a case where the numerator has a lower degree than the denominator, so it's going to approach 0. Okay.